So in the previous session, I showed you how to break out of the laptop and use different AWS services to train at scale. Okay, and we looked at EC2, container services, etc. And I mentioned, okay, there's an extra step that you can take that I think makes it easier to generally train and deploy models, even at small scale, not to mention scaling to a really, really large infrastructure. And this service is SageMaker, and that's the focus of this session. So I'm going to explain what SageMaker is about. And then I'm going to show you two demos of training models with SageMaker. One using a built-in algo in SageMaker, and the other one using Keras code and TensorFlow. Okay. So coming back to what I was explaining this morning, the fact that we're trying to build stuff that lets everybody out there, every developer, use machine learning. Where does SageMaker live, right? So SageMaker lives in that middle layer that we call ML services. And over time, we added extra services around SageMaker, and I'll show you some of them today. So we're definitely not at the top level, because here the game will be bring our own data sets, potentially bring our own machine learning code, have full control over the machine learning process, but at the same time without messing around with infrastructure at all. Okay, we can use any size of infrastructure in just one line of code. Okay, and I'm not making this up. You can see the code for yourself. Okay. So sometimes, and some customers, they want to do everything themselves. They have to do it for their own good reasons. And they need to manage their own infra, create their own instances, etc. Okay, so here, again, we'll focus on the middle layer. 100% of our time spent on machine learning, 0% spent on infrastructure. Okay? So the purpose of SageMaker is to let you go from experimentation all the way to scalable production with the same service. Okay. In the previous talk, I said I guess you could start working on your laptop and then move to EC2 instances and the deep learning AMI, and then move on to bigger things, etc. Okay. Here we're going to do the whole cycle basically, using the same service, using the same SDK. Okay. So you don't have to go and learn 10 things. This one service lets you do everything, okay? And I have to say it's a popular service. Okay, it's a popular service. I think it found its audience. People who want to focus on machine learning, and there are millions of ways to do that. Like I said, built-in algos or existing code, etc. And never worry about infrastructure. Never worry about Docker containers and Docker clusters and whatnot. VPCs. Just do machine learning. Okay, and you'll find again, very traditional company and more innovative companies, startups, etc. So, it works well for a lot of different companies. So this is the typical machine learning cycle. And you start from your business problem. You try to frame it into a machine learning problem. You try to understand what kind of data helps you solve that problem. Sometimes it doesn't work, right? Not all problems are machine learning problems. But assuming this one is, you start then to collect the data and integrate it and clean it and visualize it, understand what it is you have available. And then, so that first column is really critical in getting good results. And then once you have clean data, you can start doing the actual machine learning part, building features, engineering features that are more expressive, more useful in training a model. And then train and tune and measure accuracy, and probably looping quite a few times until you get the accuracy that you want. At some point, you get a model that you like and you want to deploy it in production, send some data to predict, and of course, you need to make sure it runs fine. Over time, you need to retrain it, etc., etc. So that's the machine learning cycle. So I keep saying machine learning is engineering, because when people talk about machine learning, most of the time they will talk about that, right? 5 minutes into the discussions, into customer discussions, it's like, oh, you're talking about which algo and which deep learning architecture to use, and I'm like, whoa, 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 whoa. Can we please go back to the early problem? What's the question you're trying to answer? Okay, what are you trying to do? You know, keep it simple. Maybe one of the high-level services works for you, right? Even with some customization. So let's not go into that crazy cycle unless we need to. Okay. So in the previous talk, Alex gave you a great overview of the different services involved in those early steps, right? Ingesting, aggregating, converting, querying, even visualizing with QuickSight. I should definitely add QuickSight to that slide. Okay, so that's, I guess, one of the advantages of doing this stuff on AWS, is that all those services, they fit together very well. So any data in S3 or Kinesis can be collected, cleaned, aggregated, etc., and prepared for machine learning. Okay, so assuming people like Alex have done their job, very good talk, and of course they have, then, okay, we move into machine learning. Okay, so we can do some visualization of our own. We use our popular libraries, you know, matplotlib, and try to understand what the data looks like, and then we run feature engineering and we train and evaluate, and that's the scope of SageMaker. Okay, and then of course we need to deploy and keep an eye on the models, and again SageMaker helps with that. Okay, so that's the problem that SageMaker solves. Okay. And yes, technically you could say some of that stuff could be done on SageMaker as well. You know, you can definitely clean data, etc., etc. But I tend to believe the other services that we covered are a better fit for that. Okay. So when we talk about SageMaker, we really talk about three things. We talk about building models, so designing models. We talk about training, and we talk about deployment. So we try to help you focus 100% on ML in those three topics. So let's start with building. So building means experimenting, okay? Trying out different algorithms with a small data set, a fraction of the production data set. So again, like I've shown you in the previous talk, you could absolutely do this on your laptop. You could do this on an EC2 instance. I mean, the choice is yours. But we've found, you know, talking to customers, that they all end up using the same things, right? They use Jupyter notebooks, they use TensorFlow, they use scikit-learn, they use all those cool libraries. And so we said, okay, let's simplify everything for customers. We're going to build what we call notebook instances, which are fully managed EC2 instances that you can create just in 1-2 minutes. And as you open them, you jump directly into a Jupyter notebook. Okay, so let me show you what I mean by that. So I created one already because we don't want to wait for 2 minutes. Okay, so I have a notebook instance, and if I click on open, okay, I jump straight into Jupyter. It's all pre-installed. I can clone my repos, and I have all the Conda environments as well. Okay, all the Conda environments are available just like on the Deep Learning AMI, and you get to work immediately. Okay, so unless you really, really like to set up this stuff yourself, which I honestly doubt, you can use notebook instances. Okay, and they come in very small sizes, T2, T3, all the way to really big ones, P3, C5, etc. If you really insist on doing cleaning here. Okay, so no time spent on setting up your dev environment, so to speak. Okay. Then once you have that notebook instance, the next step is, okay, let's try to play with some data, try some algos. Okay, but for a lot of people, it's actually very difficult to write machine learning algos. Okay, they haven't been trained to do that. And I would think, you know, they don't even need to do that. Okay, there are plenty of algos out there that have been written and optimized. So again, listening to customers, we added a collection of built-in algos, and we'll see the list in a few minutes, that you can just take, configure and use for training and deployment. Okay, so you will not write a line of machine learning code for those. And we have some pretty advanced stuff in there. We also have a collection of built-in frameworks. So again, scikit-learn, TensorFlow, MXNet, PyTorch, etc. are pre-configured, pre-optimized. Okay, same versions that you would get on the deep learning MI, deep learning containers. Okay, it's all consistent. So that, okay, once again, you don't have to install TensorFlow because that's not really a high-value task. So once you've figured out which algo to use and you want to train at scale, okay, and we can do some training on the notebook instance, as I will show you, to local mode. But once we want to train at scale on the full data set, then we need managed infrastructure, okay? And this is what SageMaker does. And it's really a couple of lines of code just to grab any number of instances of any type to get the job done, okay? So all fully managed. And we can do a cool thing called hyperparameter optimization. Who has already heard about that? HPO? Okay, a few people. Okay, so HPO is an automated way to find the optimal parameters for the training job. Okay, and this, I'll talk about this later. This is typically a complex and difficult task, and I think we make it very, very simple. And once you have a model that you like, that is accurate enough, you can deploy it in one click if you're the clicky type, one API call if you're the API type. And you can deploy it either to for batch prediction, or you can deploy it for real-time prediction using an HTTPS endpoint. Okay, and if you use that second solution, you can also apply auto-scaling, just like on EC2, to scale the prediction fleet automatically according to some metric. Okay, so over time, so SageMaker was launched at reInvent 2017, so a year and a half ago. And we've been pretty busy. We added tons of stuff. I'm going to cover some of them, some of those items, not all of them. So again, if you took a look at SageMaker, let's say a year ago, you definitely need to look at it again. A lot of stuff has been released everywhere. Okay. The one feature I want to mention is the machine learning marketplace. So you're probably familiar with the EC2 marketplace, which is a way to grab third-party software pre-installed on EC2 instances. Well, we've done the same for machine learning models. Okay, so before you go and on that 6 months project, maybe you should take a look at those models. Maybe one of them works for you, and you can very easily deploy them to SageMaker, test them with your data. If they work, fine, job done. And if you're a machine learning company, you should definitely consider publishing stuff here. Okay, it's good for reputation, visibility, and if it's a successful model, then you can make some money with it. Okay, so this is absolutely open to AWS customers. So how do we work with SageMaker? So SageMaker, just like everything else on AWS, is a set of APIs. Okay, and actually we have a new SDK in Python, which we call the SageMaker SDK, that lets us write and configure training and deployment activities. Okay, so it's very high level compared to the usual SDKs. If you know Boto 3 for Python or the language SDKs, this is really high level. This is really specialized for SageMaker and machine learning. So the objects that we work with are really machine learning objects and not infrastructure. Okay. There's also a Spark SDK. So if anybody using Spark? Okay, a few people. So I won't cover this one today, but we also have a PySpark and Scala SDK that you can use on Spark to run SageMaker training and SageMaker deployment from your Scala or from your Spark app. Okay, Spark and SageMaker together are a super powerful combination. Again, not covering this, but ask me questions, and I also have a webinar on this I can point you to if you're curious. So obviously, we also have service-level APIs for SageMaker that you can use with the command line interface or any of the language SDKs. But again, these are low-level APIs that are fine for automation, production, etc. But when we talk about experimentation, running stuff interactively in notebooks, we really want to use this one because it works with high-level objects and it's much simpler. So under the hood, surprise, surprise, this is based on Docker containers. Okay, so when we talk about built-in algos, built-in frameworks, we really mean we have a collection of training and prediction containers in Amazon ECR, our Docker registry. And so when we write code in the notebooks, right, when we use that SageMaker SDK, and we'll do that in a few minutes, we write what I call helper code. And because it's not machine learning code, okay? It's just code that says, this is where my data lives in S3, okay? This is the training algo, training container I want to use. These are the parameters that you should use for the training job. This is the amount of infrastructure that I want, now train. Okay? And you'll see it's very little code. And when we run that training job, what SageMaker does is it's going to create the infrastructure that you requested. So let's say you ask for 3 C5 2XL instances. So it's going to create those, pull the training container to the instances, point those instances at your data in S3, inject the parameters, blah, 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 and launch the training job. Okay? Once the training job is complete, the model is saved in S3, and the training instances terminate automatically. So that's one of the good things about SageMaker. You will never run any training infrastructure running for no good reason, just like you might do on EC2 or ECS or EMR or all those instance-based services. Here, it starts on demand and it terminates as soon as training is complete. So you only pay exactly for what you use, right? So now we have a model in S3, and for deployment, we could do the same. Okay, we could do the same thing. So we could run just a couple of lines of code, say, hey, please deploy this to 2 M4 XL instances for real-time prediction. And again, SageMaker will create those instances, pull the right prediction container, set up an HTTPS endpoint in front of those instances, and that would be ready to receive data and predict. Okay, so literally creating infrastructure for training and prediction, it's going to be one line of code. Okay, so you don't really need to know that stuff unless you want to build your own container, as we'll see in a minute. So when you want to train, your options are use one of the built-in algos. Okay, we have 17 of them. So just select that algo, configure the parameters, and train. Use one of the built-in frameworks. Okay, so I call this bring your own script or bring your own code. So you have existing PyTorch code or existing scikit-learn code. You want to run it at scale on SageMaker. It's easy to do. Or you have something else. So anybody using R? Okay, quite a few people. Okay, so let's say you use R or C++ or something different from all of that. You can very, very easily create your training container, your prediction container, and use SageMaker. Okay, you can literally run anything, any machine learning workload on SageMaker. We have examples for all of that. I'll show them to you. So, quick word about the built-in algos. So here's the list. Oh, there's a fancy color code that doesn't work at all with the projector. Okay, that's all right. So you'll see that on the slides, which you will get. So we have some supervised algos, linear learner, factorization machines, KNN, XJBoost, etc. We have some deep learning algos for image classification, object detection, etc. And we have some unsupervised algos like clustering with k-means, PCA, random cut forest. Somebody mentioned this morning anomaly detection. I don't know if you're still in the room. If you are, this is the one to look for. And we have quite a few. So some of them are well known. Okay, they've been around forever. But these are Amazon implementations, so super scalable, and we have benchmarks showing that this is faster, cheaper than anything else out there. Happy to share that. And some of them are actually Amazon invented algos like Blazing Text and DeepAR. These are Amazon algos published in research papers, so you can look at those. So 17 algos covering the most popular machine learning use cases out there. And I guess we'll keep adding a few, if customers ask for that. So let's look at a first example. So I'm going to use the image classification algo, a built-in algo, which is deep learning based, and let's see how that works. Oh, come on. Yes, that's the one. And yeah, I guess we need that one. Okay. So here, let's say my business problem is I would like to build an image classifier for this data set. Okay, it's called Caltech 256. Okay, Caltech is an American university. So I guess that's why the first category is a machine gun and the second one is an American flag. But okay, anyway, and the baseball bat and the baseball glove. So American standard items. And you have 256 classes. Okay, all kinds of things in there. Let's look at ducks. Okay, why not? Okay, so plenty of ducks. But we have only 87 images. Okay, and if you've tried image classification before, you know that's definitely not enough to train from scratch. Okay, the rule of thumb, if there is one, is you need probably 1,000 images to train from scratch, especially complex objects like ducks. Okay, so 87 is not enough to train from scratch. And as a matter of fact, this data set has about 15,000 samples. Okay, so if you divide 15,000 by 256, you see roughly we have, let's say, 70 or 80 images per class on average. So that's not enough. Okay, so we can't train from scratch. So we're going to use another technique. Let me zoom in. Yeah. We're going to use another technique called transfer learning or fine-tuning. Okay, I will explain. So first of all, the only dependency between SageMaker and the rest of services is I need an S3 bucket. Okay, because that's where I will put my data set and that's where I will save my model. Okay, so I just need to grab. Well, I can use the default bucket, right, which is this. Or I can, it's in my own account, obviously, or I could use any S3 bucket. Okay, so fine, we need a bucket. Then we want to select that image classification algo, okay, that built-in algo. So it's a container, right? So it's as easy as saying, okay, give me the name of the image classification container in the region I'm running in. Okay, so I can use this simple API, say, hey, give me the image name for the image classification algo in the region I'm running in. Okay, and I can easily find the region because it's in my Boto 3 session. And okay, I can see the name here, right? So that's the repository ID, and it's hosted in ECR in the Ireland region. And this is the latest version for the image classification algo. Okay, all right, fine. So I know which algo I want to use now. Fine. The next step is to grab the data set. So I downloaded those files quite a few times, so they're already on my notebook instance. I have a training set and a validation set. It's already split. And as you can see, it's packed in a file format called record.io, which is it's a record format that packs those thousands of images into one single file. So it's very convenient because I don't have to move 15,000 files. I can just move this one. Okay? So here I'm not going to do any data cleaning or anything. The data set is just fine the way it is. So I can upload it directly to S3. Okay, so in my bucket, under the train prefix and the validation prefix, I upload those two files. Okay, define the right path and display them. Okay, so the training channel is here, the validation channel is here. Okay, data in S3. No worries. Then I need to define dataset properties. So basically, they're saying you'll find the training dataset is under this prefix, right? It's in record.io format, and you can fully replicate it to the training instances, meaning you can copy the dataset to the training instances. We have another feature called pipe mode, where you can stream data to the training instances. So if you have a petabyte of data that you want to train on, you can stream it to the training instances instead of copying, of course. We do the same for validation data, and we put that stuff in a Python dictionary, okay? So now I can configure my training job, okay? And I'm using this estimator object from the SageMaker SDK, which is really important, probably the most important one. So what are the parameters here? So please configure a training job with this algorithm, and that's the container name. use one P316XL instance. Okay, so that's a GPU instance with 8 NVIDIA GPUs. And save the model here. Okay, and the role and the session are just technical objects. We can ignore them. Okay, so when I say, it's one line of code to configure infrastructure, that's what I mean. Okay, if we needed 10 GPU instances and distributed training, we would just do this. Okay, so you will never install a training server again. Okay? It's all fully managed. So one is all I need. Then I need to set hyperparameters, so parameters for the training job. And of course, these are detailed in documentation. Some are mandatory, so here I'm sticking to the simple ones, the mandatory ones, and we'll see about the weird ones in a minute. So this is a deep learning based algo. It's actually a ResNet architecture, which is a famous image classifier. I can select different sizes, different depth. So here I will go with the smallest one, which is 18 layers. Okay. I want to use a pre-trained model because I am not training from scratch. Okay, I'm using this technique called transfer learning, where as I don't have enough data to train from scratch, I'm taking a model that has already been trained on a huge data set, and I'm just specializing it, so to speak. I'm just applying a little bit more training with my own training samples. Okay, and the image I take all the time is imagine you've practiced the decathlon for 10 years. Okay. So you know about the 10 events in decathlon, and now you want to be a javelin thrower. Okay, you want to do only javelin throws. So chances are you don't need to train for 10 years to be really, really good at javelin, right? Because you've done that before and you've done similar things before. Okay, so maybe in 6 months you become really, really good at javelin because you've had all this prior training that is kind of related to the task. So it's the exact same thing here. This model has been trained on a huge data set which has all kinds of objects that kind of look like the ones we have in Caltech 256. So we can just train for a little bit. In fact, we'll only train for 10 epochs, which is very short. 10 times we'll go through the full data set. When you train from scratch, you typically train for 200, 300 epochs. Okay, so we definitely want to use a pre-trained model. The number of classes is 257, so it's 256 plus what they call a clutter class, which is a class full of crap images that helps with training. The number of samples, and we want to do some pre-processing on the images. We want to generate additional samples, cropping and altering colors, etc., to make the model more robust to weird images, okay, weird quality. Okay, so again, these parameters are algo specific. They're not difficult to understand. So we could just go and train, calling fit, passing the training channel and the validation channel. So that would train for 10 epochs on that fully managed instance. And then we would have a model, and we would call deploy, and deploy that model to an HTTPS endpoint. Okay? But, come on, we can do better. There are plenty of other parameters, right? And as you start with machine learning and deep learning, pretty quickly you hit that wall. It's like, I don't know which values to pick. If you look at the algo documentation, you have parameters for, mini batch size and learning rate and momentum and additional technical parameters. And which value should you pick? Right? So usually people they think they know best, right? So they pick values and because they read a blog somewhere. And that's fine, okay? But how do you know this value is actually the right one? Okay? The other parameters that are set, okay, they are not ambiguous, okay? I know how many classes I have. I know how many training samples I have. Fine? These ones, I don't really know, okay? So the sad story is we don't know what we're doing. So we can use this technical model tuning or hyperparameter optimization in SageMaker, which is one of the coolest features in there. Asking SageMaker to explore ranges of hyperparameters, training different models and keeping the one that is the best, okay? So we know maybe from experience or from the literature that, okay, batch size is typically between 32 and 2K, And learning rate is typically between 0.001 and 0.2. And momentum is typically between 0.9 and 0.999. If you had 50 data scientists in a room, you could get them to agree somehow, after some fighting, that yes, these are reasonable ranges. Now, which value do you need for that specific training job? That's something else. So we're going to define those ranges. We're going to ask SageMaker to optimize for validation accuracy. That's the metric we want to keep an eye on. So the best model is the one with the highest validation accuracy. Okay, so we want the maximum validation accuracy. And then we create this hyperparameter tuner object, passing the estimator that we configured above. Okay, that one. And the metric name and the parameter ranges and how many jobs we want to train. And here we can train, let's say, 10 jobs 2 by 2. And it's not random at all, okay? It's not SageMaker picking random values and training 10 times and giving you the best one. It's SageMaker training, let's say, 2 jobs first, and then applying machine learning optimization to predict the next 2 sets of parameters you should try. Training 2 more times, and then predict it again, training 2 more times, predict it again, until you've done 10. Okay? So it's not random, okay? It's machine learning. It's a machine learning process where, based on the accuracy that you got from a specific set of hyperparameters, predict what to try next, okay? And it's based on complex machine learning algos, and if you really want to know the names, they're called Bayesian optimization and Gaussian process regression, and they help you converge quickly to the optimal job. If you were doing random search, which you can also do in SageMaker, you would probably train 100 jobs, not 10. Okay, because random is dumb, and this isn't. Okay, each step uses machine learning optimization. Okay, so then we can train. Okay, calling fit, and if I look at the SageMaker console here, I can see my 10 jobs, right? That's probably a little tiny. Okay, so I see those 10 jobs. So that's, I guess, the first one, and I can see the accuracy. And I can see the next one was a little better. The next one was ugly because probably we explored a little too far. The next one was actually very good. And yeah, we even have a better one here. Okay, so it's a trade-off between finding a model that performs well and staying around that, and of course exploring other parts of the hyperparameter space. Okay, but over time you converge to high performance models much quicker than using random search. Okay, and if we look at this, the best model, we could see. Come on. Okay, we can see the actual values. So learning rate was 0.02841, and batch size was 389, and momentum was this. And of course, no one would ever have picked those values manually. Okay, so you can take the guessing away from that that process. Just set the hyperparameters that are non-ambiguous and use hyperparameter optimization for everything else. And again, you will quickly converge to high-performance models. Okay, so now we have the best model, we could deploy it. And deploying would be as easy as this. .deploy, and with the infrastructure requirements. And again, if you wanted to deploy to 10 instances, backed by backing one HTTPS endpoint, you would just say 10, and SageMaker does everything. But we have this cool new service called Elastic Inference. It just works like this. Instead of deploying to a GPU instance, you deploy to a CPU instance with an elastic accelerator. And they come in 3 sizes: medium, large, X large. Okay? And so this is a fractional, it's a fractional GPU, pretty much. Okay? So if you have a very heavy model that does require a full GPU, then fine, do this, right? If you look at GPU utilization and it's at 90%, 95%, okay. You do need a full GPU, and that's okay. But a lot of models don't need that. So you end up using GPU instances, for example, this one, which is the least expensive one, at $1.36 per hour on demand. Okay, and if you use C5 plus the medium accelerator, you get very similar performance at 80% discount. Okay, so again, unless you need, that's the training log here, unless you know you need a full-fledged GPU instance, and you could see that with the CloudWatch metrics, GPU utilization, etc. Unless you need that, then elastic inference is probably a great way to save a ton of money on GPU inference. Okay, so you get GPU speed at CPU cost. Okay, and you can quickly benchmark if you need medium large or X large. Okay, so again, that's another cool tip. So 2 cost-saving tips. If you use EC2, make sure you use Spot, right? And if you deploy to GPU instances, make sure you look at elastic inference first. So this works on SageMaker. This also works on EC2. You can attach accelerators to any EC2 instances. Okay, and you can save a ton of money. In this case, you would almost save $800 per instance per month. So that's a ton of money. Okay, so now we have an endpoint, and we should see it in the console. Endpoint. Okay, here it is. And I can see the URL. Okay, so it's an HTTPS endpoint. So here I'm going to use the SageMaker SDK to invoke it, but you can just HTTP post images to this from any language and get some predictions. Okay, and this is backed by that C5, that accelerated C5 instance. Okay. So let's grab an image. Okay, so this is actually one of the classes in Caltech 256, surprisingly. It's not just AK-47s. And let's predict it. So I'm predicting it with the predict API. So I'm invoking the predict API on the endpoint, passing an XImage payload. Okay. And I get the 256 probabilities for each class, but I'm only interested in the top one. And the top one in this case is the right class, Buddha. Okay, let's try a second one. All right, so that's a pretty obvious one. Okay, it works too. Okay, so here's an example of the basic SageMaker workflow, putting some data in S3, selecting an algo, setting parameters, configuring an estimator. So I could call fit and deploy. I would only train one model, so I hope I would have picked the right values for the parameters. If I'm not so sure, then before training, I can use hyperparameter optimization and make sure I deliver a high performance model before I deploy it. Okay. Did we write any machine learning code here? Not really. Okay. We only had to understand some of the hyperparameters, but these were the easy ones, right? And let HPO do the rest and find the right values. Okay, and you can get state-of-the-art results with this. So all the built-in algos work the same. Again, you will get the slides. So here are some other examples. So blazing text is a good one to try. You can do, for example, text classification. You can use XJBoost for classification as well. I did a workshop at reInvent that goes pretty deep on XJBoost for a binary classification model. So if you for the next long winter night, this will take you 3-4 hours to complete. So you can take a look at that one. And we have plenty of additional examples. I'll give you the link at the end. Now, what about built-in frameworks? Okay, what about using TensorFlow, scikit-learn, etc. So let's look at another example using Keras and again model tuning and elastic inference. And you will see how easy it is to actually reuse. Here we go. Oh, come on. Where's that? Okay, that's interesting. Oh, it's here. It's gray on gray. Okay, thanks. Very. Okay, poor colors. Okay, here we go. So here, I want to run a Keras script. Okay, Keras TensorFlow script on SageMaker. So let's say I wrote that code. Okay, and it's running on my laptop, and I want to move it to SageMaker. Okay, so here's the actual code, some arguments. I'm training a simple image classifier, a simple CNN on the fashion MNIST dataset. Okay, so simple CNN. It's pretty much hello world when it comes to Keras. Okay, so training, saving in TensorFlow, serving format. So what do we need to do here? So here's the fashion MNIST dataset. So it's a drop-in replacement for MNIST. So same number of classes, same image size, 28 by 28 pixels, black and white, 60K samples, etc. And it's just more fun to play with than MNIST, and more difficult to get good results with. Okay. So first I will download the dataset, upload it to S3. Okay. Again, no cleaning required here. And I want to show you that you can really run the same code on your laptop and on SageMaker. And I mean the same, I mean exactly the same. So let's look at the code again for a second. So I'm getting some arguments here, okay? So epochs, learning rate, batch size, some architecture parameters, anything you want, okay? But when you think of it, what's the interface between SageMaker and your code? Okay, so SageMaker needs to pass hyperparameters like this, okay? It needs to pass the location of the training data, the location of the validation data, and where to save the model, right? And it's also going to pass you how many GPUs you have on the training machine, if any. So if you do this, those 4 lines, 24, 25, 26, 27, okay? If your code, and this works with MXNet, TensorFlow, and the others, if your code is able to grab those 4 environment variables and pass them to the script, that's it. That's all it takes to interface your code with SageMaker, okay? And obviously, at the very end, okay, you need to make sure you save the model in the location that SageMaker gave you. Okay, so if you can accept those 4 parameters as command line arguments, and if you save the model in the right place, that's the only change you need to do to your code to run it on SageMaker with the built-in frameworks. This is called script mode. Okay, if you want to read the documentation in detail, script mode. So the only change that I've done really is this. Now, here, okay, let's run this cell. Okay, so here, I'm not using SageMaker at all, right? I'm just calling Python on the notebook instance and running that script. And I just manually set those 4 variables, right? Okay, so this code runs on the notebook instance. All right. Now, let's make sure it runs inside the TensorFlow container. Okay, the next step, the next validation step, if you want. So we take the exact same code, 0 change, okay? We pass it as a parameter to the TensorFlow estimator in SageMaker, and we say, please train locally, okay? Instance type local or local GPU means train locally. And by the way, this also works on your local machine, right? You can do this on your laptop. Install the SageMaker SDK, select local mode, or local GPU if you have a local or local GPU if you have a local GPU on your machine, and you're going to pull the TensorFlow, the SageMaker TensorFlow container to your machine and train. Okay? All these containers are open source. You can get them on GitHub if you want. Okay, so this time I'm using the SDK, but I'm still training locally. Okay, and I can see this works, right? So here I pull the container to the notebook instance or my local machine, and it works. Okay, so now let's say I want to train on a managed infrastructure. I want to train at scale. The only change in this estimator, it's still the exact same code. Now, instead of saying local or local GPU, I'm saying, hey, train on P3-8XL, which is a GPU instance with 4 GPUs. Okay? So you can see how easily you can move from local to local laptop to or really local training with SageMaker, and then fully managed training. Okay? Script mode and local mode together, they're a really, really cool tool. Okay? So again, we could call .fit and .deploy, but no. Okay, again, we're going to use hyperparameter tuning. Okay, because my script take those parameters, and I have reasonable ranges, but I don't know which values to use, right? So, same story. Please maximize validation accuracy, train 20 jobs 2 by 2. Okay, and I've run this before because it takes a bit of time. Here it is. Oh, no, sorry, that's the other one. Come on. Okay, so this run for 57 minutes. Okay, and I get some different accuracy, but the best training job is this one. Right, 92.85%. And these are the values that I tried, or that SageMaker tried, actually. I didn't try anything. Okay? So, for your training budget, this is the best model you can get, right? So, exact same thing. You can see the workflow is always the same. And of course, I want to deploy it. And again, I can use, I can use elastic inference because this is a very small model. I don't need a big GPU instance for that. I'm just happy to have a fractional accelerator. Same code. Now we go back all the way. Yeehaw. Nice. Exciting. Come on. Oh yeah, that's going to take forever. Where is that? I cannot see the elevator. It's my eyes, I guess. I'm getting old. Oh, here it is. Okay, let's... oh, here it is now. Chase the accelerator. Yeah, okay, here we go. Okay, so this trained for 230 seconds. And this is what you pay for when you train, okay? You only pay for the training time. And this terminates automatically. Okay, so again, this is really an important point. You never leave training infrastructure running for no reason, okay? So there's a good saving thing here. Oh, come on. Okay, now let's predict. Okay, so I'm just grabbing random images from the data set, predicting those 10 images, and I compare the predicted labels to the real labels. And it looks like they're all good. Yeah? That looks fake, so we need to see a mistake. 4903, 497. Damn, okay, one last try. 821, 816, 3421. Okay, so it's a pretty good model, right? So I could clean up and delete the endpoint, okay? But, okay, one extra thing. In the previous talk, I showed you how to deploy to ECS and EKS. We have another container service called Fargate. Who knows about Fargate? Okay, it's pretty good because it's serverless, whatever that means in that context. So how do we deploy that model to Fargate? Because so far, we've used SageMaker all the way, right? But like I said, use what you need, right? Maybe training on SageMaker is what you want. And maybe your company wants to deploy to Fargate. So yes, you could deploy to a SageMaker endpoint, or you could grab the model in S3 and deploy it on Fargate, or ECS, or EKS. So how complicated is that? Not very complicated, actually. Oh, come on, do I have to scroll? Can you read okay, or, yeah? Okay, hopefully. Okay, so I need to grab the best training job, okay, find its name, find the location of the model in S3, okay, and the model is actually, it's a tar, it's a gzipped tar file. So I can copy it, extract it, and it looks like this, okay, because it's a TensorFlow, it's saved in TensorFlow serving format, which is what I want here. So it's saved just like this. Then I can push this model to a Git repo somewhere, okay? It's on GitLab in this case. Create a Fargate cluster, okay, nothing bad. And run, so create a task definition for this task, okay? So this is the name of the container that I pushed to ECR, and this is this is the name of my container, the container that I'm using. This is where I'm cloning the model that I pushed to GitLab, and I'm using TensorFlow serving to fire it up. Okay. So not a complicated one. Okay, so run that task. And I can see after a minute or two, these are really quick steps, but I didn't want to waste 2 minutes to do this. So the service is running. I got the IP address here. I can build the URL for the prediction service. And we can grab some random images and predict them. Okay, and I see again the labels, and the predictions are quite good. Let's do that again. Finally we have a mistake. Okay, good. The first one's wrong. Okay, so just to show you, SageMaker is not, you're not locked in that service, where, you have to use a notebook instance, and then you have to train, and then you have to deploy. Just use whatever building block makes sense. And if it makes sense to train and deploy elsewhere, you can absolutely do that. Okay, it's, it's not a problem at all. So how do you get started? Oh, we need the scorecard. So if you were there during the previous session, my previous session, okay, this was the scorecard for EC2 and ECS, EKS. So what about SageMaker now? So infrastructure effort on SageMaker, 0. I guess we'll agree on that, yes? ML setup, none. Okay, unless you need to create your container, but really, it's minimal, I think is a good word. CI/CD integration, that's probably where you would need a little bit of work, because this is different from deploying to EC2 instances and deploying to Docker containers. So you would use, I don't know, the SageMaker SDK or CloudFormation or something, but it's totally possible to automate. Building models, well, you can start from 17 built-in algos, so maybe you don't even have to write stuff. Training models, 2 lines of code, right? Configuring the estimator and calling fit. Deploying models, 1 line of code at any scale. So scaling and high availability built in. You can use auto-scaling, and this stuff is already multi-AZ and everything else. Cost optimization, well, you will only pay exactly for what you use for training. And for inference, real-time inference, you can use auto-scaling to scale up and down. Security is built in, so if you want, let's say, volume encryption on the notebook instances or the training instances, just enable KMS. Okay, you don't have to do much. And my personal opinion is you can learn it in a few hours. Completely forget about servers. So if you're a data scientist and you have 0 love for VPCs, SSH keys, availability zones, and all that good stuff, I guess this is the one for you, right? And you have tons of goodies. I covered a few, like I mentioned pipe mode, hyperparameter optimization, but you have plenty more. Okay, I just scratched the surface. Okay, so If you're a Docker shop and you have to deploy to Docker, then okay, this is probably a reasonable choice. If you're not there, I would highly recommend that you take a look at this, but it's just me. Okay, so you've seen quite a few of those URLs before. The ones that I recommend you look at first are, of course, the SageMaker SDK on GitHub and the SageMaker examples on GitHub. Probably 100 or 200 notebooks with everything in there. This is my workshop from reInvent, and again, Medium and GitLab if you want more content. Okay, and last but not least, ask me questions now or later, and Twitter is the right place for that. I usually answer pretty quickly. Okay, thank you very much, and we have one more. Oh yeah, I'm gonna need that. Yeah, thanks.